Now let's talk about the simplest form of Coulomb's law and a general method for being able to solve Coulomb's law problems. Let's suppose that we have a point right here, and I'm going to call that S because that is my source, and that I want to find the electric field over here at some point P. That's my point. So I know that I'm going to be able to find it in this direction. That will be the direction of the electric field, and that the electric field at point P is going to be equal to my charge Q divided by 4 pi epsilon, the distance between them squared, and that's going to be in the direction from the source to my point. This right here is a unit vector going from the source to the point. So how can I easily find this? Let's suppose that I had lots of different charges and I needed to add them all up. So the easiest way to do that is to define a coordinate system with a convenient origin. So here's my x, my y, and my z coordinate system. Right there is a convenient origin for me, and right here is my first point, q1. The thing I'm going to do is write a vector from the origin right there, to my source, q1, and that is vector rs. Then I'm going to define where I want to find my electric field. Right here is point P, and I want to find the electric field at point P, so I'm going to draw a vector from my origin to point P, and I'm going to call that RP. Well, if we look at this picture, we can see that what we really want is RSP. So I want to find this vector right there, RSP. The way I find RSP is that is equal to RP minus RS. And that gives me the vector from my source to the point that I'm interested in. Then I would apply Coulomb's law right here. Q is equal to 4 pi epsilon. The magnitude of RSP is just found by taking the magnitude of the subtraction of these two vectors, and the unit vector is found by taking this vector and dividing it by its magnitude. If I had several charges, there's Q1, over here might be Q2, down here Q3, and so on, the electric field would simply be the sum of all of those charges, 4 pi epsilon, the distance ri squared in the ri direction. What that means is that each one of these has different ri vectors that are going from the source to the field point of interest. And I can find each of those vectors exactly this same simple way by taking a vector from the origin to the source and a vector from origin to the point, subtracting them, finding their magnitude as needed, and finding their unit vector as needed. So these are the steps that we're going to use when we apply Coulomb's law in all of our other examples.